Hello, this is Sal. Today's practice lab is about configuring IPv6 static and default routes. In today's practice lab, I will configure the entire network to communicate using only IPv6 addressing, including configure the routers and PCs. I will also configure IPv6 static and default routes on the routers to enable communication to remote networks that are not directly connected. On the description of this video, you will find two files, one for the packet tracer source files and the documents to walk you through the lab step by step until you finally will be able to verify the configurations you did during this lab. If you like my videos, please subscribe to my channel and recommend it to your friends and share it and give me the thumb up. And please let me know if you have any suggestions, comments, or questions. I will gladly answer you back. Now let's start by initializing and reloading the routers. I will start by enabling IPv6 routing on the routers here on router 1. Type enable, configure terminal, give it a host name router 1. Simply type IPv6 unicast routing. Next, I will configure the network interfaces on router 1 with IPv6 addresses. You will notice that IPv6 is enabled on each interface. The gig01 interface has globally routable unicast address, and EUI-64 is used to create the interface identifier portion of the address. The serial 000 interface has a privately routable unique local address, which is recommended for point-to-point serial connections. Now, what is the EUI-64? It stands for Extended Unique Identifier. It's a method we can use to automatically configure IPv6 host addresses. An IPv6 device will use the MAC address of its interface to generate a unique 64-bit interface ID. However, a MAC address is only a 48-bit, and the interface ID is 64-bit. Now, if you'll ask, how is it constructed? The IPv6 EUI-64 format address is obtained through the 48-bit MAC address. The MAC address is first separated in two 24 bits, with one being OUI, which stands for Organizationally Unique Identifier, and the other being NIC specific. Now I will continue the configuration of router 1 with the interface of gig01 and the IPv6 or version 6 address of 2001 colon db8 colon abcd colon a colon /64 space EUI -64, and we will enable or activate the port with no shut or no shut. Now for the other interface of serial 001 IPv6 address of FC00 colon 1 /64, also activate or open the port with no shut. Next, I will configure or doing the configuration on router 3 and within global configuration mode to enable IPv6 routing. So on router 3, enable configure terminal, give it a host name of router 3, and now IPv6 unicast routing. Now, I will configure the network interfaces also on router 3 with IPv6 addresses. Now, you'll notice that IPv6 is enabled on each interface, The gig01 interface has a globally routable unicast address, and EU I-64 is used to create the interface identifier portion of the address. The serial 000 interface has a privately routable unique local address, which is recommended for point-to-point serial connections. Now the clock rate is set because it's the DCE. It's the DCE end of the serial cable, and it must provide a clocking on the wire. So now back to router 3 with the interface of gig 01. Now IP version 6 address of 2001 colon DB8 colon ABCD colon B double colon /64 space EUI hyphen 64. Activate or enable the port with a no shut command or no shut command, no shutdown. Now the other interface of serial 000 IP version 6 address of FC00 colon 2 /64, also open the port with no shut. Now for the clock rate, I will use the 128,000. And we did the no shut. Anyway, next I will configure the PCs to obtain an IP version 6 address automatically. They will contact the routers to obtain the network subnet and gateway information and auto-configure their IP version 6 address information. What I'm going to be doing is I click on the PC icon, then I click on the desktop tab, then IP configuration, then IP version 6 configuration, and then I'll click on the auto configure. This way, the PC will obtain its IP version 6 automatically from the router. So the icon of the PC, go to the desktop tab, IP configuration here, and under IP version 6 configuration, just click the radio button here, and it will obtain its IP version 6 address from the router. And I'll do the same with PCC. Click on the icon, desktop, IP configuration, under IP version 6 configuration, just click on the auto configuration and it will receive its IP address, IP version 6 address from the router. Now, if from PCA, I will open the command prompt and type IP version 6 config space /all, we should see that the PC now has an IP version 6, a global unique address, a link local IP version 6 address, and a link local IP version 6 default gateway address. Yeah, command prompt. If we type IP config space all, we did not configure anything with version 4, IPv4, but here IPv6 config space /all, as you can see here, as we said on PCA, that the PC now has an IP version 6, a global unique address, a link local IP version 6 address, and a link local IP version 6 default gateway address. We may also see a temporary IP version 6 address, and under the DNS server addresses, 3 site local addresses that start with FEC0. Site local addresses are private addresses that were meant to be backward compatible with NAT. However, they are not supported in IP version 6 and are replaced by unique local addresses. We are not seeing it here on this example, but we may, but we didn't. Anyway, now the router output, sorry, the PC or the output when we type IP version 6 config all on the PC, the PCA received IP version 6 addressing information from the router, from its router or its gateway. Notice the PCA global unicast address, also the link local IP version 6 address, and also the default gateway IP version 6 address. Here at the bottom, DHCP version 6 client DUID, which stands for DHCP Unique Identifier. This used to identify clients and servers. Next, here from PCA, I will use the ping command to issue and IP version 6 ping to the link local default gateway address. Here on PCA, this is our default gateway. I want to ping it from PCA. Just type ping and paste. And then we should receive a reply from, and the ping was successful. Sorry about that. My voice is barely, my throat is sore and I have a runny nose and I'm coughing, and that's why I sound weird. Sorry about that. I live in Texas. It's hot already here, and it's really bad when you have a flu, especially in the summer. Sorry about that. Now, we pinged from PCA its default gateway and it was successful. Now, I will repeat the same thing on PCC. Here, we will type this command first on PCC IP version 6 config // as this is the default gateway on PCC, copy, and I want to ping it from PCC and paste, and it should be successful, and it is. Now the output, as you can see here, also on PCC, that PCC received IP version 6 addressing information from the router, which is router 3. And also notice that the PCC global unique address, also the link local IP version 6 address, and also the default gateway IP version 6 address. Next, I will attempt an IP version 6 ping from PCA to PCC. Now we are on PCC. Go to this. Here we have the physical address, which is the MAC address for the NIC on this PC, but the IP version 6 address for this PC is this. So I will copy this and ping it from PCA. Copy, then go to PCA and attempt to ping from here. Ping space and the address of PCC. It should fail. And as you can see here, it's telling us destination host unreachable. Why? Because both routers are still not configured with static or dynamic routing. They only reach the directly connected networks. Next, I will use show commands to verify IP version 6 settings. I will check the status of the interfaces on router 1 with the show command. So on router 1, and here, I will use this show command, show IP version 6 interface brief. This is on router 1. Notice the IP version 6 addresses for the Gigabit Ethernet 01 interface. Link local address, the one is starting with FE80, and the global unique unicast address. And we can notice the same thing for the interface serial 001. To see more detailed information on the IP version 6 interfaces, I will run this command, this show command on the router. Show IPv6 interface. Here it will give us more details. As you can see, this is for the interface of serial 001, and before that for the interface of gigabit Ethernet 01, telling us this is the IPv6 is enabled. The link local address is this, starts with FE80, the same here with the serial 001, this interface here. Now I have a question here. What is an FF02::1? This guy here. This is used for all nodes in the local network segment. What about the other IPv6 address here? This is FF02::2 multicast address. What is used for? This is used for multicasting to all routers in the local network segment. And what kind of multicast address are FF02::1, FF00:1, and the FF02::1? And what are they used for? These addresses are solicited node multicast addresses. Each interface unicast or any cast address has to have a solicited node multicast address for resolving neighbor addresses on the local link. Now, I will view the IPv6 routing table information for router 1 using the show command, show IPv6 route. The IPv6 routing table should have two connected routes, one for each interface, and three local routes, one for each interface and one for multicast traffic to a null-zero interface. Now, that's why when we review the routing table here on router 1, show IPv6 route. Here for router 1, it's showing us the directly connected, this interface here via the gigabit Ethernet 01, and the directly connected the other interface here, but none about this network here. That's why we were unable to ping from PCA to PCC, because the routers, this router doesn't know anything about this network, and router 1 doesn't know anything about, it's not in its routing table. Sorry about that. Next, I will configure IPv6 static and default routes in three different ways. I will confirm that the routes have been added to the routing table, and then I will verify successful connectivity between PCA and PCC. The three types of IPv6 static routes. Type 1, it's directly connected IPv6 static route. It's created when specifying the outgoing interface. Like for router 1, the outgoing interface is on serial 001, and the outgoing interface for router 3 is on the serial 000. Type 2, which is recursive IPv6 static route, it's created when specifying the next hop IP address. This method requires the router to execute a recursive lookup in the routing table in order to identify the outgoing interface. The next hop for router 1 is this interface on this IP address FC00::2/64, and for router 3 is this IPv6 address here. Now type 3, which is default IP version 6 static route. It's similar to quad 0 IP version 4 route. A default IP version 6 static route is created by making the destination IP version 6 prefix and prefix length all zeros, ::/0. Now, I will configure directly connected IP version 6 route. In a directly connected IP version 6 route, the route entry specifies the router outgoing interface. A directly connected static route is typically used with a point-to-point serial interface. Now on router 1, I will configure an IP version 6 static route to this network here, to 2001 :db8 :abcd :b :/64. And I'll use router 1 outgoing interface, which is this interface here. So on router 1, configure terminal. The command goes like this: IP version 6 route to 2001 :db8 :abcd :b :/64. It's incomplete because we still need the outgoing interface, which is serial 001. So we configured a route from router 1 to this network here through this outgoing interface on router 1. Now let's view the IP version 6 routing table to verify the new static route entry. So back to router 1, do show IP version 6 route. It's showing us here with this, the S letter, to this network, which is this network here, and it is directly connected, but via what? The outgoing interface, which is serial 001 here. Now if we try to ping PCC from PCA, it should fail. Let's give it a try. So now from PCA, first I need to go to PCC, and I want the IP address for PCC. It's here highlighted. Copy, goes back to PCA, type ping, and then paste. This ping should fail. Why? But if the recursive static route is correctly configured, the ping arrives at PCC. It will arrive here, and then PCC sends the ping reply back to PCA. However, the ping reply is discarded at router 3 because router 3 does not have a return route to the 2001 :db8 :abcd :a :/24. It doesn't have anything for this network. That's why it's not showing on its routing table. Where is it? Then it will discard it, the ping or the reply back. Now on router 3, I will configure an IP version 6 static route to this network here. And I will be using router 3 outgoing, which is this interface here. So on router 3, enable, configure terminal, IP version 6 route to 2001 :db8 :abcd :a :/64, and the outgoing from router 3 to this network here on router 1, the outgoing interface will be this. which is serial 0, 0, 0. Now that both routers have static routes, let's ping again from PCA to PCC. On PCA, just use on the keyboard the up arrow and hit enter. And as you can see, we have a reply back. Why? Because router 3, it has on its routing table for, let's do this here, do show IP version 6 route. Let me expand this a little bit. As you can see here, it's showing a static route on router 3 to this network here or router 1 via this interface. So the ping is successful. Next, I will configure the recursive IPv6 static route. In the recursive IPv6 static route, the route entry has the next hop router IPv6 address. First, I will delete the directly attached static route on router 1 and then add the recursive static route. So on router 1, I will type this command here, do show run or do show running config. And this is what I configured here, this command. So I will copy it. And here, just simply type no, and then paste, and then enter. Now I will configure the recursive route. The command goes like this, IPv6 route to 2001 colon db8 colon abcd colon b double colon /64, and this will be this next hop on FC00 colon 2 /64. There's something wrong here. IPv6 route 2001 db8 abcd and FC 00 double colon 2. Next, on router 3, this we did the configuration on router 1. So I'll do the same on router 3. First, I will type the command do show run or do show running config, and I will go to this command here, copy it, directly attach the copy, and here just simply type no, and then paste this command, and then hit enter. So now I'll configure a route to this network here, and this will be our next hop. So on router 3, IP version 6 route to 2001 colon db8 colon abcd colon a double colon /64, and it will go through the next hop on FC00 colon 1 /64. What am I doing wrong here? Double space. FC00 colon 1 without the 64. So now I will verify the static route entry on router 1 by viewing the IPv6 routing table. So back to router 1, type this command, do show IP version 6 route. And as you can see here, it's showing us that there is a route from router 1 to this network here, and it is via the next hop of this IP address or this interface. And the same on router 3, do show IP version 6 route. It's showing us that there is a route to this network here of router 1, and this is via the next hop on this interface. So let's try to ping PCC from PCA again. Upper arrow, enter, and we receive the reply. Why? Because on router 1, on its routing table, it knows about this network, so it can reach it, and on router 3, it can ping this network here from PCC to PCA, because on router 3, it is in its routing table, it knows about this network here. Next, I will configure a default IP version 6 static route. In a default static route, the destination IP version 6 prefix and prefix length are all zeros. Now, just like we did in the last time, before configuring the default static route, I will delete the recursive static route and then add a default static route. So on router 1, do show run or do show run in config. I'll go to the same command here, this guy here, copy, and at the bottom just type no, and then either click here paste or anywhere here and click, so it's gone. So now to configure a default IP version 6 static route, the command goes like this: IPv6 route :/0, and we want this from router 1. This is outgoing interface of serial 001. Enter. And I will do the same also on router 3. Do show running config. I will go to the command, which is this guy here, highlight it, right-click copy, and then type no, either click on paste here on the right or right-click your mouse and then paste and then hit enter. Now type the command IP version 6 route :/0, and on router 3 the outgoing is on this interface of serial 0/00. Enter. Now let's view the IP version 6 routing table on router 1 to verify the new static route entry. So on router 1, do show IP version 6 route, IPv6 route, and as you can see here, it's showing us, and this from to any network, it will go via this interface on serial 001. And the same will run this command on router 3. Do show IP version 6 route. And as you can see also here, and it will be via the outgoing interface here on the serial 00. So let's try from PCA to ping PCC again. And we received a reply and the ping was successful. And that's it for this video. Thank you so much for watching, and please, if you have any comments, just contact me, send me a message on Facebook or a comment here, and I will gladly answer you back. And sorry about the way how I sound because of this really bad flu. Thank you so much for watching, and I'll see you soon in my next video. Have a nice day.